The main components are the Kelly, the rotary table, and swivel. The Kelly is a 40-foot-long pipe with an outer hexagonal cross-section that connects to the top of the drill pipe. When drilling, the Kelly passes through the Kelly bushing. The Kelly bushing has 4 pins, which slot into 4 post holes in the rotary table on the drill floor. The rotary table turns to rotate the Kelly bushing, thus rotating the Kelly and drill string. The rotary table is controlled from the driller's console and can turn in both clockwise and counterclockwise directions. The swivel is found at the top of the Kelly and supports the entire drill string weight. The swivel also allows mud to be pumped down the drill string while the string is rotating. Most offshore drilling rigs now have a top drive system to rotate the drill strings. The top drive uses a power swivel at the top of the drill string in place of a Kelly and rotary table to rotate the drill string. The power swivel connects to the traveling block, and both components run along a vertical guide track extending from below the crown block to within 3 meters of the rig floor. The power swivel is powered by a large electric motor and is remotely controlled from the driller's console. The main advantage of a top drive is that 90-foot stands can be added to the drill string rather than the conventional 30-foot singles. This saves rig time by eliminating 2 out of every 3 connections. The circulating system is used to circulate drilling fluid, called mud, down the drill string and up the annulus. The mud carries the drilled rock cuttings from the face of the drill bit to the surface. The mud is constantly recirculated, but only after the rock cuttings are removed at the surface. 4 major components make up this solids removal equipment: shale shakers, desanders, desilters, and centrifuges. Mud first passes over the shale shakers, which remove the largest rock cuttings. Desanders, desilters, and centrifuges remove increasingly smaller rock particles. Any gas brought up by the mud must also be removed by passing the mud through a degasser. The cleaned mud is then ready for recirculating. Mud tanks, sometimes called mud pits, are a series of large interconnected steel tanks. Some mud tanks are used for circulating mud, while others are used for storing fresh mud. Clean mud is picked up from the appropriate mud tanks by positive displacement plunger pumps. These powerful pumps increase the mud pressure to thousands of pounds per square inch, providing the energy to circulate the mud. High-pressure lines carry the mud from the pumps to the rig floor, where it passes through the standpipe, the flexible rotary hose, the swivel, and the hollow Kelly. The mud continues back down the drill pipe to the bit face, completing the cycle. The purpose of the well control system is to prevent a blowout. A blowout is the uncontrolled flow of formation fluids into the well bore. A blowout may cause environmental damage, loss of valuable oil and gas, loss of equipment, and, most seriously, loss of life. The well control system must allow the driller to detect the influx of formation fluids, and close in the well until the well can be made safe to drill ahead. One of the first signs that formation fluids have entered the wellbore is a level increase at the mud tanks. This is because fluids entering the wellbore push the mud out of the hole. Mechanical devices such as pit level indicators or mud flow meters will trigger alarms and alert the rig crew to the influx. If necessary, the well can be closed in with blowout preventers. Blowout preventers, or BOPs, must be installed on top of the well before drilling even begins. BOPs are basically hydraulically operated high-pressure valves designed to either seal off the annular space around the drill string with rubber elements or seal off the entire wellbore by driving metal rams across it. Normally, both types of preventers are used on a well and are stacked up one on top of the other to form a BOP stack. Now that you have completed this module, you should be able to identify various drilling personnel. Describe how these personnel work together during the process of drilling a well. Identify 5 types of drilling rigs. Describe which type of rig to use in a specific environment. Identify and describe the 5 subsystems that comprise drilling rig equipment. In the section on personnel, we learned about employees of both the operating company and the contract company. We also learned what their responsibilities are and how this is influenced by the type of drilling contract agreed upon. A few third-party personnel sometimes needed at the rig were also discussed. The drilling rigs section introduced us to both land and ocean rigs. We took a further look at the different types of ocean rigs, including jackup rigs, semi-submersible rigs, drill ship rigs, and fixed rigs. We also looked at what drilling locations were most appropriate for each rig. The drilling rig equipment section described the major equipment used for hoisting and rotating the drill string. This section also discussed the power generation system, the circulating system, and the well control system. If you are still unclear on any of the objectives, now would be a good time to go back and review.